Okay, welcome back everybody. So today is the last couple pages of the packet. So have your packet out on your iPad. In a moment I'm going to ask you to turn it my way. Everybody please zoom it in on problem 34. I just want to make sure that you're actually with me. This is the part where cell phones need to be away. Headphones need to be out of your ears. And I need your full attention. And then we'll have a bunch of work time at the end. Okay? So please zoom in tight on that first problem. It should say x plus 4 squared plus 3 so that I can see it. Like really tight, like zoom, 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 so I can see it. Thank you. Okay, good. Still waiting. Good, good, good. Thank you. Avia. Thank you. I'll catch up with you in a second. All right, here we go. And I'm going to start with a little thing for the vertex that's so easy. If it's in this form, there's the vertex, except it's not 4, 3. Be a little more careful. Is what? Negative 4, 3. Because when it's in that form, the vertex is just sitting right here. What if it wasn't in that form? What if it was in some other form? Well, then you have to do, I'd write this down, x equals negative b. Can anybody remember the rest of that little formula that tells you the vertex x over 2a? Very good. You may want to study that right before the final. So write it down right now. So when you're just about to start the final, you can be like, oh yeah, there's that one formula, negative b over 2a. We're going to do one like that. So here's one. That's a quadratic. What's its negative b over 2a? Well, I can see b. It's just sitting right there. Over 2 times a. It's not hard. So Jackson, what's the b? Yep. So negative b would be over 2 times a, which is? So what's my final answer?
It's 3 over 4.
You forgot the negative. Negative 3 over 4. That's the x of the vertex. So what's the rest of the vertex? Well, that's a nasty one. But you'd have to take that and stick it in the equation. You couldn't do that unless you had a calculator. But you will have a calculator. Okay? So you just stick negative 3/4 in here and here. All right, did you just take good notes on that? Negative b over 2a is big formula. It's on this test. Like as forget it. Okay, all right. So that's how you find, now that's not the y-intercept though. The y-intercept's actually a lot easier. Can you answer this or finish this sentence for me? The y-intercept is where x equals 0. Very good. The y-intercept is where x equals 0. So all you got to do, no matter what kind of fraction or problem you have, if you want the y-intercept, you put in x equals 0, wherever you see x. See? And this it says y equals negative 7. Now some people are going to be like, it's just the one at the end. That's all you got to do is pick the one at the end. Nope, not true. Because look at this one. The y-intercept is where x equals 0. So this becomes 2 times 3 times negative 5. That's the y-intercept. It isn't the number at the end. The y-intercept is where x equals 0. If you haven't already written that down, you're not really taking good tips for yourself. Things to remember right before the final. Like in that last 20 minutes before you're about to start the final, you can go, yeah, how do I find a y-intercept again? Oh yeah, I set x equal to 0. Okay, now this one wants the x-intercepts though. How do you do that? That's where y equals 0. So here's my equation. Where's the y? That's the y. So if that equals 0, how do you make that equal 0? You make this part 0 and that part 0. Would you please try this one? It's problem number 37 in your packet. Everybody just solve that one. If you're having a really hard time, you're overthinking it. You just need the parentheses to be equal to 0. And pause for a second while you give that a shot. Okay, this one should have been easy. x equals -3 here, because, you know, put a -3 in and you get it to equal 0. And this one, I'd make 4x minus 5 equal to 0, and then it's just a little two-step equation. You add 5, and you get 4x equals 5, and then you divide by 4, and the answer is 5/4. Raise your hand if you had those two. Awesome. That should be the happy place on the final. Convert to standard form. Let's just multiply it out. The one thing kids do wrong, though, is they don't start here sometimes. You should start there and do the FOIL thing, but what do you have to remember to do at the end? Hello? Come on, help out here. After you're done multiplying out the stuff in the red box, then you times it by 2. Good. Times everything by 2. All right. How about this one? Well, you still multiply it all the way out. But some people are going to think this is x squared and 4 squared. Is that how that actually goes? No. It's x plus 4 times x plus 4. And then you subtract 8. All right. Axis of symmetry. You know that other one I said was for the vertex? It's also for the axis of symmetry. Maybe you should write it down there too. You do negative b over 2a. And it's actually simpler because you don't have to like find the other part. You just figure out what b and a are, stick them in, and you're done. Your answer would be like x equals 10. It's not the answer, but I'm just saying your answer just looks like that. But it won't be 10. All right. Here, if you can't find the vertex out of these 3 points, I'd be kind of disappointed. So, duh, the vertex is there. How about the axis of symmetry? It runs right there, and it's called the axis of symmetry. Everybody put x equals right there. It'd be really easy to forget. It's an axis. It needs to be x equals. Now, x-intercepts, that's just where it touches the x-axis. That's the x-intercept, that's the x-intercept. How about the domain? I'm just going to write left to right. Does this function keep going forever, left to right? If so, you'd say like infinity comma infinity. Range, that's how low to how high it goes. Does this keep going up forever? No, it's got a highest spot. And then the last question is a value. A lot of people ask about that one. And I get that's kind of obscure. Looking at this graph, what's the a value? Well, if you look at an equation that's like this, y equals 2x squared plus 3x plus 6. Let's say it was that. Okay. What's the a value? Well, it's this value. Well, how am I supposed to know what that is for this? Because it's upside down, what can you tell me about the a value? Because this is flipped, what's this number gotta be? Negative. That's all you gotta say. If it's upside down, it's got a negative a value. That's what they're getting at. It's just, is it positive or negative? You don't have to know exactly what the a value is. Technically, it's a negative something, like a -2. In this case, it'd be a -2 because you go over and then you go 2 spots instead of just 1. But the main thing is that the a value is negative. That's all I care that you know. So that this is upside down. So the number in the front is the a value. If they had said, is the number in front negative? I hope you would have gone, well, yeah, it's upside down. Well, the a value is the number in front. That's the a value. Okay, moving on to this page. And then there's only one more after that. This one's all about factoring. And man, I practiced a lot of factoring with you. And you guys actually really rocked the factoring test. So I think this one won't be too bad. How about if I just do number 45 with you? Would you agree there's an x in both of them? Would you agree there's also a 5 in both numbers? then you can factor out the 5x. So when you do that, it's like you're really dividing this by 5x and dividing this by 5x. So that'll tell you what you should put here. What should you put there? X. Because if you do 5x times the x, you get 5x squared, just like we had in the first place. And this one, 60 divided by 5, oh, I'd be grabbing my calculator pretty fast. Good. Then it's 12. And don't forget what sign to put. Well, there was a plus, so we put a plus. There. I factored that one for you. Now you should be able to do this one. If you get stuck, come up and ask. But it looks like there's a 10 in both things. All right. Now what happens when it's like this kind? You make 2 parentheses, and it was a 3-step process. X and X, plus and plus. Do you get, if there's only pluses, it's like easy level. If there's a plus and a minus, then you got to know if there's 1 minus and 1 plus. You can think it through and figure out whether it's 2 minuses or 1 minus. But there has to be at least 1 minus if there was a minus in it. Like this one, there's got to be at least 1 minus. So 3-stepper, X and X, always that. Then this one will be a plus and a minus. You know how I know? Because at the end you have a negative. That means a positive number times a negative number will make the negative. And then you got to figure out what numbers go in there. So I would be telling a lot more if I was teaching you factoring for the first time. But this is all like stuff we've learned. Here, you'd start by factoring out the 2 first. Then you can factor it again. So that's my tip on 47. All right. These special kind, I'm not going to do the easy one. I'm going to do the medium one. See if you can get how these work again. I said it's always a 2-step process. Do you get how 2x and 2x make the 4x squared? Now there's a minus. What did I always say about a minus? Then there has to be at least 1 negative. So I'm going to do a plus and a minus. And last I do the square root of 9, which is a 3. And if you actually multiply this all the way out with firsts and the outside and the inside and the lasts, this part would cancel, and I got the original problem back, which is exactly what I wanted. So number 48 and 50 are just like that. And last but not least, and it's even a super short page, yay. Notice we're not going to ask you to do everything from the quadratics test. Do you get that the final would be like half quadratics if we did that? So it's just a couple of the quadratics things. Notice we aren't making you remember everything about quadratics. But what's one thing for sure? Got to be able to simplify these things. And a lot of people had trouble, so let's do one of them together. I'm going to do the 48 with your help. Make 2 square roots. And somebody smart goes into 48. What times what? 16 and 3? Ooh, that's a good one. I know some of you would have said 2 goes into it, and it would have, but 2 and 24 doesn't work real nice, whereas 16 and 3 works real nice. Why? Because that one's perfect. So then that's 4 root 3. Okay, now this one, solve using the quadratic formula. No decimals. That means at the end, when you have like 2 plus and minus the square root of 8 over 6, you have to be able to handle stuff like that. All right? Well, I'm going to just show you that. I know that's not one of your questions, but I know what your final is like, and there's a question like this. So let's do it together. Square root of 8. Everybody think for a second and figure out what that is. It's like 3 root 2, but it's not that. I'm glad I heard 2 square roots from the kid who was like suggesting what it might be. 2 square roots is a great way to start. Root 4, root 2, and then that's 2 root 2. Raise your hand if you had that one right. Cool. Then I rewrite the thing. Try to do too much in your head, you're doomed. There. I just did one thing and I rewrote it. Now, a lot of people are like, can't I just cancel these two? No, you can't. Why not? Because this is part of an add-subtract problem. So instead, my favorite saying, if you can factor it, you should. That can be factored. There's a 2 in both parts. And the 6 could be factored into a 2 times a 3. And then those 2's will cancel later. But let's get this part. That's the only hard part. Liv, can you tell me what would be inside that parentheses? Yep. If you're like, how did she get that? Well, we divide this by 2. We divide this by 2. And that part's 1. And that part's 1 times the square root of 2. That's why we got those 2 things. And then these will cancel, and that's how you leave your final answer. Just like that. I know that looks like it's not simplified, but it is as simple as it can get. The numbers are pretty small. But I have a calculator. Why don't I just use a decimal? Because it says no decimals. Otherwise, sure, it would have been a lot easier. Just do that on a calculator. But it said no decimals, so that probably implies the test will be like that too. So don't just ram everything into the calculator. If it says no decimals, you got to do this process. Okay, I am happy to say that is the last thing that I need to teach you. And now we just have some time for review today. We'll have some time after lunch to review. And then tomorrow's kind of weird. You're used to having a break in the middle of my class, and tomorrow's going to be 2 hours long. Not tomorrow. Wait a minute. You guys have it the next day, right? Thursday. Yeah. You guys have it Thursday. So when you do have the final, it's 2 hours long. Your lunch will be before this class. Okay? Your lunch will be either, yeah, we'll figure it out. But we will have a long honking final. So bring a book or something to read, because when you finish the final, I'm not going to be able to have cell phones out, at least until I'm down to only like a couple kids left. Okay, so just have something to do. Yes?
How long is the final take?
The final time's 2 hours long, and how long should it take you to take the final? I'm not telling you how many problems it is because it's kind of irrelevant. If I told you it was like 15 questions, you'd be like, oh my gosh, that's so easy. But what if they all had 5 parts? So I can tell you that it should only take you less than an hour of the 2 hours. But you'll have 2 hours. So if you want to stay the whole time, you can. Now, if you have an extended time and we give you 2 hours, well, then that means you get like 3 hours. Okay, and if that's the case, you can have the time, but you're going to have to do it in a row. You're not going to be able to just take the whole test, see the whole test, and then have more time on the test. Now, if you want that to be divided up into chunks, if you've got extended time and you want it to be divided up into chunks, I can just give you half the final, and you can finish that and be completely comfortable. And then you can do it in chunks like that. That way, you make sure that you don't end up with too much to do in one time period. What I'm trying to say is, if you want extended time, I need to give you the final like 1 page at a time. And you just keep doing as much as you can until the end. And then if you don't have time to do the last page, you'll come in a different day and do it. Maybe after school. Yes?
How much does it affect our grade?
Fair question. This is not as big. My honors pre-calc class, it's 10% of their grade. For you guys, it's more like 5% of your grade.
So it's its own thing?
Well, of course it's its own thing, but the question is, like, how big of an impact does it have on your grade? Again, a typical kid is going to, an average kid is going to stay at the same grade as they were. Really rare for a kid to blow the top off the final and then raise your overall grade. That's pretty rare. It's also pretty rare for a kid to completely fail their final so bad that it lowers their grade. So you can probably figure that whatever your grade is going into the final, unless you really screw things up, it'll probably be the same. And if you're super close to the grade above you and you really want to get it bumped up because you're like, oh my gosh, I'm so close to an A minus, well, then you'll have to blow the top off the final. You'll have to have an awesome final. They're all R2 level questions. These are what we just went through. In that whole thing that we just went through, that was the easy stuff. There was a lot of harder stuff this semester. So these are not supposed to be incredibly hard questions at the end.
Just a lot of them.
Yeah, it's just like twice as long as a normal. Not saying exactly twice, but it's about twice as long as a normal test. Okay. And that's all I have for the video. For the rest of the hour, we're just going to do practice problems, and it's pretty close to lunchtime here. I'm confused because